on perpendicular bisectors and the circumcenter, and let's begin right away with a little bit of vocabulary. So we have here a segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called the perpendicular bisector. So let's look at some examples. Okay, so let's say I have a line segment here, A, B, and then I have some point here, C, that cuts AB in half. Okay, I can say that C, okay, is a bisector of AB. Now I can also, let's say I have a line here that goes through this point C. Let's say that's line L. So I could say that L is a bisector. But note here, I have not used the word perpendicular, okay, because that's not what it is yet. Okay. So I have not used the word perpendicular yet. So let's look at that. So a bisector just means that it's something that cuts a segment in half. But to be perpendicular, we're talking about something different. So let's say I have a different situation, a line segment from C. Let me not use C. Let's say it's from D to E. Okay, and I have a point here in the middle that cuts this in half, and a line goes through that point such that it forms a 90-degree angle. We'll call this L line 2. Now we can say that L2 is a perpendicular bisector of DE, because it satisfies both conditions. It is a bisector and it is perpendicular. Okay, so that's the basic idea here, that it has to satisfy two different conditions. And oftentimes in geometry we take these types of definitions for granted. We assume that we know exactly what it's talking about, but then we'll miss something important in there. Okay. So moving on here, we have the next definition, that it says a point is equidistant from two figures if the point is the same distance from each figure. So for example, if I have a situation like what we had before, B, A, C right here, okay, we can say that C is equidistant from A and B. That means from C to A is the exact same distance as from C to B. Okay? And we can also make a little bit of note here that AC then is congruent to BC. Okay? But this is the main point here. Okay? And so with these two vocabulary words down, we can move on to our first theorem of the lesson. So this theorem says that in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So let's walk through this a little bit and then try to draw the picture from the description. Okay. So let's see. If a point is on the perpendicular bisector of a segment, so we first need a segment. Okay. Just to mix it up, I'm going to use X, Y. And then there is a perpendicular bisector. Call that W. And this is a 90-degree angle. Okay. And the theorem basically says that any point that is on this line, that is on line L. Okay, so let's say if I have a point here, V, okay, then from V to X, it must be the same distance as from V to Y. Okay. So this, for theorems, it's very helpful if we can write them in if-then form. So this says if V is on L, then Vx is congruent to Vy. Okay. That any point on this line must be the same distance to one of the endpoints as it is to the other endpoints. Okay. And to prove this, our plan for proof is to show triangles XVW is congruent to triangle YVW. Okay. Then use CPCT. Okay, so that's our plan. So it's always nice to write out, it's always a good idea to write out a plan first before we actually get into the nitty-gritty. So we want to show that these two triangles here are somehow congruent, and then we can use CPCT with the two sides, the two line segments that we're interested in. Okay. So from the picture here, one of the things that we can start with saying is that XW must be congruent to YW. Okay, and this is given, and not only that, we can give it a sort of another reason is that W is the midpoint of XY. Next, the two angles down here are congruent, XWV and YWV, because they're both 90 degrees. So XWV is congruent to angle YWV because they are both 90 degrees. Okay. So now we have a side, we have an angle, and you can see this third side here that we're going to use is the reflexive property. Okay. So VW is congruent to VW. That's reflexive. Now I'm running a little bit out of room here, so I'm just going to continue writing on this paper. Step 4. Triangle XVW is congruent to triangle YVW by side, angle, side. And finally, because the two triangles are congruent, VX must be congruent then to VY by corresponding parts of congruent triangles. Okay. And so there you have it. This is a nice little proof that shows whatever point you pick on this line, no matter where you place a point, it must be the same distance to the endpoints of the original line segment. Okay. So I'm going to end this video here before we go on to the converse and all these other more difficult and challenging parts. I'll just say here that again, this is a proof that just reuses the idea of triangle congruence, and that's such a big and important part of this. Alright, thank you for watching. Have a wonderful day.